All right, kiddos, week 2. Here we go with equivalent ratios. So you may remember from last week, we established that a 2-to-1 ratio is really the same thing as a 4-to-2 ratio, right? There's 4 leaves here for every 2 coins. But if we do a little bit of some organization here, you might notice that there's also 2 leaves for every 1 coin. These ratios mean the same thing, and so we call them equivalent ratios. Equivalent meaning equal, essentially. And how do we know that 2 ratios are equivalent? Well, the best way to check, I think, is to put them both into simplest form, and you'll see that they are the same if they're equivalent. So an example of that, 2-to-1 is already in simplest form. And then 4-to-2 is not in simplest form, right? Because there is a number that goes into 4 and also 2. So we write that as a fraction. The number that goes into both of them is 2. And we reduce this to 2/1 or 2-to-1. And you will notice that this is the same as our other ratio, and so they're equivalent. 4-to-2 is equivalent to 2-to-1. The other way is sort of going backwards. We're going the opposite way. We have 2-to-1, and we can multiply any number to both the 2 and the 1 to get another equivalent ratio. So if we pick the number 2 and we times both of these numbers by 2, oh, I'm sorry, you can't see. And we times both of these numbers by 2, we get 2 times 2 is 4. And then 1 times 2 is 2. And we get this other equivalent ratio. Now, for every ratio, there are an infinite amount of other ratios that are equivalent to it, right? We times 2-to-1 by 2, but we could also times it by 3 to get 6-to-3. We could times it by 4 to get 8-to-4, sorry. And so all these ratios are equivalent to each other. All right. So here's a question that you might be asked, and it's saying, which of the following ratios are equivalent to 1-to-3? And so we're going to check by putting them all into simplest form and seeing which ones are equal to 1-to-3. Now, 1-to-3 is already in simplest form. If it wasn't, then I would put it in simplest form first, but because it is, we are good. Let's start with 3-to-9. We're going to write that as a fraction and ask ourselves, is there a number that goes into 3 and also into 9? There is. It's 3. So we divide the top and the bottom both by 3, and we get 1/3, which is equal to 1-to-3, which is what we wanted. Beautiful. So this one is equivalent to 1-to-3. I'm going to switch colors here, so that's a little bit easier to see. 3-to-15. 3/15. Is that in simplest form? No. We can divide these ones also both by 3. So 3 divided by 3 is 1, 15 divided by 3 is 5, and so our ratio is 1-to-5. We think. We make sure that's in simplest form. It is. And so we see 1-to-3 and 1-to-5. Those are not the same. So this one is not equivalent. And I realize that I'm missing a letter here. That's going to bug me. All right. 6-to-12. Something that goes into 6 and also 12. Let's choose 6. All right, 6 divided by 6 is 1, 12 divided by 6 is 2, 1-to-2 is not 1-to-3, So that one's no good. (45/15). We could choose 3, we could choose 5. I'm going to go with 9. I know that 9 goes into both of these. And I know in class you might normally have... Oh, 9 doesn't go into both of these. What am I talking about? 5 is what we want. No? Let's try 5. (15) is the one that I wanted, class. So this is a good example. We divide them both by 5 and we get something that can continue to be reduced. So we're going to go it again. And I know that 3 goes into both of these. Sometimes you got to do it in 2 steps. There we go. All right. And I was saying that you might normally use a multiplication chart in class to help you with figuring out which numbers go into these numbers. If you can find a multiplication chart online, or I can try and find one for you if you want me to look, just send me an email, give me a shout. That's something that you absolutely can use when doing math. You just need to find one if you don't have one. All right. Now this is 3/1. So here's a question. Is 1-3 the same thing as 3/1? That's up for debate, isn't it? I don't think so, because if we are talking about a ratio in context, pretend you have 1 bee for every 3 wasps. That's different than 3 bees for every 1 wasp, right? So I'm going to say that order matters, and this is not the same. Okay, last one, 4-12. All right, divide these both by 4, and we get 1/3. 1-3, and that's what we wanted. So the two ratios that are equivalent to 1-3 are 3-9 and 4-12. All right. Next, we've got a different type of question here, and it says make a new ratio that is equivalent to 1-3. All right. We already know 2 of them. We know 3-9 and 4-12. Now, we would get 3-9 by multiplying 1-3 by 3. Gives you 3-9. And we would get 4-12 by multiplying it by 4. Right? 1 times 4 is 4, 3 times 4 is 12. But we want a new one, and we can choose any number that we like. I'm going to choose, 20. I think 20 is a nice number. So we times these both by 20, and 1 times 20 is 20, and 3 times 20 is 60. And so that's a new ratio that is equivalent to 1-3. And we could keep going and make as many of them as we want by just multiplying both sides of the ratio by the same number. All right, so here is sort of the meat and potatoes. This is what a lot of questions are going to be asking you to do, and it's find the missing part of the equivalent ratio. This is a little bit tricky, but I'm going to do my very best to explain it in a way that makes sense. So, what we first need to do is see which side of the ratio we know both the numbers for. So we know, in this ratio, we know 6 and we know 18. We have both of the right sides of the ratio because our blank space is on the left side. And the question we need to ask ourselves is, what number is multiplied to 6 to get 18? We need to figure out what that number is. Something was multiplied to 6 to create that equivalent ratio with an 18 in the spot where the 6 is. And what number is that? So there's a few ways you could figure it out. You could be looking at a multiplication chart, finding 18, seeing what times 6 is 18. Or we could do 18 divided by 6. Either way, we're going to find out that that number is 3. Right? So 3 is that number. And then our second step is to multiply this number to the 4. So the 4 is in the same spot as the missing blank. And so then we are going to multiply 3 times 4 to get 12. And so now we know that 4 to 6 is equivalent to 12 to 18. Right? There's another way that you can set this up as well, but I think this is the most, the easiest way. And I'm sorry. I keep forgetting to move down so that you can see. In real class, you'd yell at me for that. But unfortunately, you don't get to yell at me for this. So, step 1, we figure out which side has both. We figure out what number was multiplied to 1 to get the other. And then we take that number and we multiply it to what we have to find the missing one. All right, let's try one more. So this time, the side that we have is the left side. We have 1 and we have 4. Now, 1 is smaller than 4. So something was multiplied to that 1 to get 4. And it's 4, right? We can do it this way. 4 divided by 1 equals 4. Or what number was multiplied to 1 to get 4? It's 4. So 4 is our magic number here. All right. Now we see we have our missing blank here, and the number that we're going to multiply that 4 to is a 5. And so 5 times 4 is equal to 20. And so 1 to 5 is equal to 4 to 20. All right. Now, if you want to check your work, and I'll do this as a little bit of a bonus here, we'll go down. So we'll check our work. The way that we can check our work is if we put 4 to 20 into simplest form, we should get 1 to 5, right? Because 1 to 5 is already in simplest form. So 4 does go into both of these. Surprise, surprise. And 20 divided by 4 is 5. And so we know that we have done this correctly. And you can always use that to check your work. All right, we're going to do some word problems in the next video, but I'm going to leave this here for now. Thanks for watching.